Okay, let's take a look at our exponential as well as our logarithm graphs. Okay, so what is exponential actually about? So exponential, we just have like the easiest example that I can think of, right? Is that we have our um unknown, our variable. So y equals to, our variable is in the power. So what I have here is that, right, a, right, in this case here will be a constant. So something very relatable to us is that we always replace the a with the exponential e. Okay, because if you're going to press your calculator e, right, you will realize that e actually, oops, wait, okay, so if I press E, right, see E is just a constant, right? There's no variable. So like pi is also a constant, right? So when I have this thing over here, right, I actually can see that is the only variable that we're talking about here is X and Y. Okay, so how does a Y equals to E? Let me just do it over here, yeah? How does a Y equals to E power X graph look like? If you ever forget, right? You can actually always check using the calculator. So what I will do is I will always just take my pencil. Okay, I'll take my pencil and then I'll draw like a little table to kind of see how the values will change. Okay, so I will choose x values. I'll choose a negative value. I'll choose a zero so that I know where it intersects the y-axis. Very important. Must always, they ask you to draw, you have to label where they intersect the axis. Okay, and then this is a positive 10. So when I key this, right, I will realize that this is e power negative 10. Then I have e power 0. Then lastly, I have e power 10. You look at the value, it started very, very tiny, but most importantly, right, it started positive, correct? So it will never become negative. Then when its power 0, it intersects the y-axis at 1, and suddenly it becomes very, very big. So what my understanding for this graph here, right, is that it will be, wait, so this is y, this is x, right? So it started very small, but it will grow exponentially. Can you see this? Okay, so it will just increase like that. So this is like describing your love for A math. It's just going to be more and more and more and more, right? Okay, so what happens if I am doing y equals to e power negative x? So similarly, what you will do is you can actually make use of this table as well to go and check out the shape, right? The general shape, because it's something you can press in your calculator. So it's what? Okay, let me remove everything. So it's e power, what am I doing? E power, right? There's already a minus, correct? But you're going to minus 10. You saw that? Then we got the same thing, e power 0, as well as e power when I put in, right? So it's just like that. Okay, because it's e power negative x. So when I put in positive, then there's still a negative. So it started from very, very big, intersects at 1, and then become very, very small. So what we have from here, you can actually see that your graph actually flipped lah. All right, yeah. Okay, so let me label my axis. So I started from very, very big, then I become very, very small. So one thing I want you to understand is what does this actually mean? This is a very typical exponential word problem kind of question. Okay, they will always ask you, like when we have this e power something, right? You can see that this graph here, the y, right? It actually approaches 0. Okay, it actually approaches 0. So this is something you must understand. Okay, then after that, right? Then we have our log graph. Okay, log graph is not something I have to worry about as well. So I'm going to just write down over here because I can actually cheat my, right? So let's say do log x, right? Again, right? I will try to key in this data here. Okay, so I'm going to go log negative number, right? Okay, my calculator is a little bit smarter. So my calculator will show me this kind of things, but your calculator, right, will just show you that it's a math error. So what does math error mean? That means when it's negative number, it got no answer one left. So that means if I'm going to draw, right, there's no shape, no graph at all on the left side of my y-axis. Okay, so then I have ln 0. Ln 0 is funny thing, right? Also don't know what is this, right? Negative infinity, what's it talking about? Your calculator, let me try. Your calculator will give me math error as well. So then what I'll do is then I will try to think of, like I'm going to just put in a few more values. So this one is also giving me a math error. So cannot have any values, yeah? Then I extend this one here, right? Okay, I'm going to put in a bit smaller value. So I'm going to put in like 1, then 2, 3. Okay, we'll see what happens. Oops, wait. So 1, 2, and 3. So when I do ln 1 is 0. What's ln 2? Oh, a bit bigger now, 0 0.6. Ln 3, oh, 1 point something. So what do you realize? Then you continue. You see how is it growing? So ln 4, how come it's becoming closer and closer, huh? So it's like slowing down. Can you see that? Okay, at first it was like a quite big difference, like almost 0 0.4, right? So you can see, how come like that? Even at ln 10, right? If I do ln, wow, very small. So then what does this tell you? So when we do our ln graph, right? Okay, what we understand is there are some places we cannot have any value. So when x is negative, no value. When x is 0, also no value. So my graph starts from here. And it's going to grow like that. It's slowing down. Can you see that? Okay, wait, I should draw properly. So it looks something like this, slow down, slow down, slow down, slow down, like that. So this is my y equals to ln x graph. Can see? Okay, so one thing you need to remember is, right, every time we do logarithm and ln, right, they behave the same way. What? The rules are all the same. You split, you open, whatever, all the same, right? So this is also how my log AX look like. Okay, how my typical log graph looks like from here. All right, so you can always remember this general shape here. So the one thing I want you to realize is, right, if let's say okay, I want to do the relationship because the base of ln is what? The base of ln is e power something. The base of log, right, is 10 power something. So what I need you to understand is that your ln graph as well as your exponential graph, your e power x, okay, it will always reflect along this diagonal line of y equals to x. So you see it's a reflection. Let me try to draw it nicely. I try my best. Wait, it's here, it's here. Okay, so it will be like this. Okay, it's a reflection. My hand's so shaky. All right, it's a reflection here. So one thing you can see from here is that, right, you must understand that this value over here, right, you can see, right, when x equals to 1, y is equals to, so they will expect you to label all your x and your y-intercept. X don't have, okay? Y-intercept like that. So you sub in to check lah. So you just let x be 0 or let y be 0 to see what we have from here. Okay, so this is your log graph. So if we're going to look at like typically like some questions that I can see, right? Let me show you examples. Give me a second. Okay, so if I'm taking a look at this one, right, the first one, we're going to sketch this graph, which is y equals to e power x, right? Okay, so this one quite generic. Just remember exponential. Exponential is just like your love for a math. So when you draw your axis y and x, it should look something like this, and then it starts going up. So this is a y equals to e power x graph. Okay, so what happens when this happens here? Let's compare, okay? So if ever you forget, remember it works with a table. Why my hand so trembly, huh? Okay, so here, so I'm going to put in my x and my y. Okay, so I will have what? So I'm going to see my negative 10, 0, and 10, right? Then I'm going to do at the side. Maybe I do on top here, okay? Y equals to 3 plus e power x. So when I have this one here, I'm also, never mind, I draw. Okay, so from here, I'm also going to put in my x and y. So I won't compare. Okay, so I put in my x and y. So here also negative 10, 0, and 10. Okay, let's do the y equals to e power x first. So e power x will be e power negative 10. This is my answer, right? But what happens when I take 3 plus e power negative 10? It will just be, can you see, it's just 3 more, lor, correct or not? So if it's 3 more, that means it will be like 3 steps up. Can you see that? It will be 3 steps up somewhere here. Okay, then what happens if it's e power 0? I think we know it's 1, right? But if I take 3 plus e power 0, it becomes 4. So this one was 1. So now I'm going to go to 4. Okay, then next thing I'm going to try e power 10. I think you can already see the pattern, right? So e power 10, this is like that, right? So when I do 3 plus e power 10, I shift up by 3 steps again because 22026, 22029, right? So then it will be 3 steps higher, so like that. Okay, so when you draw it, right, then it will cross, then it will like that. So it's just shifting up by 3 steps now. Can you see that? Wait, let me adjust a bit. Okay, so it will just, okay, not very nice, but it should be like very, very, how to say, like every point is like parallel, 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 nice, nice, go up like that lah. Okay, but remember you have to show me this point and this point. Then label your graph lor. Y equals to 3 plus e power x. So after you get the hang of it, right, you remember the shape. You don't have to always plot. But we're just practicing this for maybe one question only, or just try to see the understanding from there. So if you don't want to purposely go and memorize, exponential is something you can plot this way. Ln also can. Just remember ln and log behave the same way. Okay? So what happens here is that how are these two graphs different? So they are different because this graph cuts the y-axis at here. This graph cuts the y-axis at 4. That's all. Okay, simple as that. All right. If I give you another example, something that tests your understanding from here. Let me flash. Let it load. Okay, so this one here, you're going to sketch this graph, right? So if you ever forget, same thing, you're going to plot the table. Okay, so you plot the table. Anyway, the shape is either going up or going down, correct? So let's say I do this, right? So I got like this and then like this, right? So I'll put in again, negative 10, 0 and 10. That's key. So e power is already minus, then 2 times negative 10, e power, yeah. Wait, how to use it? E power negative 2 times 0. Last one, e power negative 2 times 10. So you realize that from very big, intersect at 1, become very small. So just going to sketch it out from very big to very small, huh? Okay, so like that. Actually, I don't need to draw so high. It will never go below, right? Okay, so this is my y, this is my x going down. Okay, like this. Okay, so then from here, label, this one here is 1. Okay, so what is this? So they say hence, alamak, hence means what? Hence means must use the graph on top, right? So when you have your hands from here, how to show that there is only one solution. One solution means one intersection lah. Understand? Okay, one solution means one intersection. So what I have from here, right, is that we are going to see that we have to represent it a different way. So this is this one here, right? But in order to do this one here, I need to make sure, right, the one of the side, right, can be replaced with this one. So I know like y equals to something. So you see, what do I mean by that? Y equals this, and then, I mean, x equals to this, like that, right? So, right, what is this one here? This one, if you understand, I'm sure you do indices, right? This one bring down becomes this. Agree with me? So I can bring this guy over, right? So when I bring this guy over, x is 1 over e power 2x. So when this thing happens, right, do you see this is the same as this? So that means it's y, correct? So I'll replace this side with y. So x is equals to y. How does a x equals to y line look like? If you need to, you can draw. It's a diagonal line. So you will do like x, y. So I'll same thing like, okay, but I put 2 points enough because it's just a straight line, okay? Fast forward. So I'll do like maybe, okay, never mind, I shall not be lazy. I shall set a good example, okay? So what I have here is negative 10, 0, and 10. This is also negative 10 based on this, right? This is also negative 10. This is 0. This is 10. So that means there will be points like 0, 0, then 10, 10 is like here, then negative, then it's like that, right? So it's just a straight line like that, correct? So when I draw my straight line from here, what do you notice? Okay, this is y equals to x. This is y equals to e power negative 2x or 1 over e power 2x. Then you realize, right, the solution is always talking about the intersection. So since there is only one intersection, or the y equals to x, okay, intersects y equals to e power negative 2x at 1 point. So therefore, there is only one solution. Okay, so this is your exponential and logarithm graph. Remember, exponential you can always plot to check the general shape. Ln also can. Logarithm, if you're ever confused, just understand that it behaves the same way as ln, okay? But important thing to remember for logarithm is that this one and this one, they must always be positive. All right? Okay, so this is your guide. You're just practicing this for most likely your Sec 3 WA3. If you have exponential logarithm, they usually will test this. And then you're just practicing for one questions in your final exam, okay? So know the general shape.